Hi, my name is Brad Cunningham. Today I'm going to talk to you about the TODO application and how we ported it over to iOS. If you have been following along with this video series, you'll know that we started this application in Windows Phone and then we ported that application over to Android, and now we're going to go ahead and port that over to iOS. So if you haven't already got the code, you can do so by going to GitHub and looking for TIG cross-platform mobile. We're hosting all of the code here publicly in a GitHub repository. So you can go there and pull the code down. When you do that, you'll want to go, and if you'd like to see the completed code, the completed application with all three platforms, you can pull that code from our master branch. If you'd like to get the iOS code skeleton without the code actually filled in, you can do so by pulling that from the iOS branch. So this will be a branch with the framework for the iOS project, but a bunch of the code elided away, and we just have some comments to explain what you need to do. Also, if you're following along on the Learning Line project and using learninglineapp.com to follow along with this series, there will be a series of labs that you will go through that will walk you through the steps to build this application. So to get this code, I used an application called SourceTree. It's downloadable from the Atlassian company, the same people who make Jira. And SourceTree is just a nice IDE or a nice GUI for working with Git repositories and Mercurial repositories. Ours is on GitHub. SourceTree makes it very easy. Of course, you can always just do GitHub from the command line like most people are familiar with, and that works just as well. So I'm going to pull down the master branch and walk you through the completed code here. So I've got the most up-to-date master branch pulled down from SourceTree. And what I want to do is open that in Xamarin Studio. So let me minimize these away and we'll go over to Xamarin Studio here. And I'm going to open my application. So I'll just navigate to where I've got this code stored on my local machine. And I'll have to remember where I stored it. Here we go. So right there, TIG cross-platform mobile, we'll go into our to-do and you'll see that there's a to-do solution file. So if you're familiar with Visual Studio, this is the main SLN that you would open in Visual Studio. We're going to open that here in Xamarin. So I'll go ahead and double click to open. You'll notice that you get two errors usually, and that's just telling us that the Windows Phone 8 code that we're trying to open will not open on Xamarin Studio, and that's because Xamarin Studio only supports Android and iOS development. They don't actually support Windows Phone because they figured if you have to do Windows Phone, you've got to be on Windows and you're going to have Visual Studio at that point, so no need to support that. So you can just go ahead and say OK to that error message. And when Xamarin comes up, then once you say OK to the error message, you'll see that we've got three projects, four if you count the Windows Phone that doesn't load. We've got the Android project from our previous video series. We've got our common project that we've been sharing code across all of our apps with, and we've added a new project here called TIG to do iOS, and this is our iOS specific application. So if you watched our Getting Started video for iOS, you'll be familiar with the anatomy of this iOS project. Again, we'll walk through these high-level pieces. This looks very similar to what we saw before. We have a main.cs, and this is our main entry point into our iOS application. It's literally the static void main method, and you don't normally have to care about this. The only piece that you need to be aware of is that this line of code here is telling the application that the class called appDelegate will be registered as the delegate for our application. And what that means, if we go over here to the appDelegate class, again, if you're familiar with C# and the term delegate, it's going to be a little confusing here because the word delegate in iOS does not mean the same thing that it means in C#. In iOS, it literally means the class that will act on behalf of your application. And in this case, what that means is that it is setting up what the main window of our application is, and it is setting up what the view controller for our application is, and then it is hooking the Windows root view controller to the view controller it just created. So iOS apps, again, are built in a MVC pattern, a model view controller pattern. In this pattern, our controller is called TIG to do iPhone view controller, and our view is the window here, which is a new UI window that is set to the size of the main screen. So we've created the V and we've created the C in the MVC pattern, and we wired that up in our app delegate. And then what we want to look at is the TIG-to-do iPhone view controller. We can do that one of several ways. We can right click on it and we can say go to declaration, and that will take us right to that file. You can also go in your Solution Explorer and double click on it and get there, and it will take us right to our TIG-to-do iPhone view controller. And there's a couple methods in here. One is whether you received a memory warning or not. We don't care about that for now. What we do care about is view did load. And view did load is when our view is shown on screen. What code are we going to run? So let me go ahead and run this application so you can see what it looks like, and then we will be able to see what this code is doing. So I just went up and pressed play in Xamarin Studio. It builds and it launches and it shows waiting for the debugger to connect. And what it actually created is my emulator. I'll drag it on screen here. I've got an emulator with a list, an add button, and a text box. And when I click it, you can see the on-screen keyboard comes up, and I can say task 1, and I can click the add button, and we can say task 2 and click the add button. And you can see these tasks get added. And now when I click on a task, I can check it to mark it as complete or uncheck it. And I can also swipe to the side to delete a task. So that swipe to delete is a behavior that's familiar to iPhone users. And so functionally what we wanted to add is the ability to keep a list of tasks, the ability to mark a task as completed, and the ability to delete a task if we no longer want it. So that's what our application is doing. I'll move this off screen here. I'll come in and stop running. And then I will walk through what we did. So we have one view in our application. It's the TIG-to-do iPhone view controller. And from that view, we have a list control that holds a list of tasks, and we have the ability to add and remove tasks from that list. We have a text box that allows you to type in the task, and a button that allows you to add the task to the list. So what we're doing here is we create our Task Manager class, and we'll notice if we right-click on Task Manager and say Go to Declaration, and then look over in the Solution Explorer to see what item is highlighted here on the left, you can see where this class lives. It lives in TIG-to-do Common. This is a common DLL. This is a portable class library, and this DLL, this code, this compiled DLL is shared across all of our platforms. So this is the same DLL we used in our Android application, the same DLL that we used in our Windows Phone application. So if you've followed along with this series, you should be familiar with this common class. You should be familiar with Task Manager. This is the same code. We haven't had to modify this at all, actually, to get it to work for iOS. Once we made the slight modifications to refactor it to support Android, now we have a class that works across all three. So we'll go ahead and close this, go back. So we create an instance of our Task Manager when our view loads, and we're storing that Task Manager as a class, a private variable as, of our controller class. So we hang on to a reference to that. And then when the view loads, then what we're going to do is we're going to wire up some event handlers. So here's our add button, and we're wiring up to the touch up inside. If you watched our previous video, you know that that's equivalent to click. So when you click the add button, what we want to do is call add new task. And we have an additional event here. We'll get to this in a minute. This is just some hooking to let you use the enter key on your keyboard. So we'll revisit that in a second. And then down here we have table tasks. That's actually the name of our list of tasks we show at the bottom. We set its source property to this class called new tasks table view source, and we'll revisit this in just a minute. So let's focus on the add first. So when you touch up inside the add button, we call add new task. If we look at the bottom, here's our method add new task. And this is calling functionality on our task manager, which is the class that lives in our portable class library. So we're telling the task manager to set its new to-do items text property equal to new task text.text. And this guy, if we hover over it, you can see is a UI text field. That's the text box that's actually on our form in the application. So if we go back to our emulator and I bring this on screen, this text box here that triggers the on-screen keyboard to come up, this is new task text. And whatever we type in there, when we click this add button, we want to take that text, assign it to the property in our task manager, and then call the task manager's add method. And then we want to clear out the text from the text box. So this is leveraging our common code to shove the task item into our list that we're maintaining, and then clearing out some UI. So let's look at how this UI is laid out. So in iPhone, to look at the UI, what you want to do is go over to your Solution Explorer and look for your XIB file or zip file. This is the Xcode Interface Builder file. And in Xamarin Studio, they drive you towards building the UI in Xcode. You don't build it in Xamarin Studio directly. So when you double click on an XIB, like I did just there, it's going to start Xcode. And you're going to see it says, welcome to Xcode. And what it launches is our application. I'll shrink this up so we can see it. It launches our TIG TODO iOS application. And you can see we've got kind of a Solution Explorer type thing over here on the left for Xcode. And we're inside this XIB, and now we've got a design surface. And you can see that design surface is a text box, an add button, and a list. And if we bring our running app back on, you can see that's what we get, a text box, an add button, and a list. And you can see this list is filled in with some fake data. This is just for testing purposes to be able to see what the layout of your table list looks like. So if we then go in here, we can click on these, we can edit sizes, we can do all the drag and drop type stuff that we want to look at. What we want to look at is the event handlers and how that's wired up. So how did we give a name to these items? How did we name the text box, and how did we name the add button? In Xcode, that's done by going over to the top menu here, and you go over to the assistant editor, which is this second icon in with a little bow tie. You click on the assistant editor, and that opens up a split screen panel. And that split screen panel is showing you one of two files, either your controllers.m or your controllers.h file. We want to switch over to the .h, or the header file, if you're familiar with C-based languages. We want to switch over to the H file, and you can see in the H file that we've got some outlets here in iPhone, what's called an outlet. That's an interface builder outlet. That's basically a naming connection to what's in the front end file. So we've got a UI button called add button, and if we click on this guy, and if we wanted to wire these up, you can right click and drag, and that's how we added these things. So this one is already connected together, so I'm not going to do that, but if you wanted to name these things, you would left click on them on the design surface, then you would right click to drag them over, and you would drop them here to insert an outlet. And that would give you a little pop-up. In fact, let's just drop one here and see. That would give you a little pop-up and let you give it a name. And when you give it a name, that creates a reference here. We called it add button. And as soon as you do that, when you save, you have to make sure to press save in Xcode, which is Command S or File Save. As soon as you save in Xcode and you flip back to Xamarin Studio, over here on the left is your controller file. Underneath the controller file is a designer file, and that's a generated file, and it says so at the top here. This file has been generated automatically by Xamarin Studio to store the outlets and actions from the UI designer. So when you generate outlets in Xcode and save them, Xamarin picks up those changes and puts those in as properties into the partial class here, the designer partial class for your controller. And notice this is a partial of my controller. So back here we were looking at the other part of the partial for our view controller, and that's where we were looking at the view did load. And so that's why we're able to say add button dot, and it knows what add button is. It's because the Xcode designer, when the save happened, that code was pushed back into Xamarin, or Xamarin picked up those changes and wrote it into your designer file. So that gives us the ability to wire up to those various UI elements. So just one more time, back in Xcode, we've got a design surface. You can drag and drop controls from the lower right panel in Xcode. You can click on the object library and you can see a list of all the controls that are available to you. You can drag and drop one of these by left clicking and dropping. Let's put a label here. And then if you wanted to reference the label, you'll have to, in code behind, you have to create what's called an outlet. You can do that by right clicking on the element, dragging it, and dropping it inside your .h file somewhere. It doesn't really matter where. As soon as you drop it, it asks you for a name. We'll call this my label and press OK. And now you can see that this property here is created in Xcode. Now I haven't saved yet. And if I go back to Xamarin and go to the design file, you'll see that that's my label is not listed here yet. So Xamarin hasn't noticed a change yet because I haven't pressed save. So I'm going to go up here and go File, Save, and then I'm going to flip back to Xamarin Studio, and there it just refreshed, and now you can see my label is available. So that's how we're wiring up the UI, and I actually want to go ahead and delete this guy because we don't want that in our app, so I'm going to delete it, and I'm going to get rid of this property here. Notice you can edit both sides. I'm going to save over here in Xcode, flip back to Xamarin, and now it refreshes, and that's gone. So that's the basics of how we wired up the UI and how in the view did load, we're able to hook up to the touch-up inside. Now we added a list here below. We'll bring this back on screen here. We'll say task 1 and click add, and task 2, and you can see they're showing up in this list with a little animation, and when you click on them, there's checkboxes, and when you swipe, you get a delete behavior. So that's that control in iOS is called a table view, a UI table view, and those controls have actually two properties on them. They have the in iOS land they have two properties for the data source and the what's called the delegate. And so if we just back off here and say delegate. In iOS, if you've done any iOS at all, you're familiar with these two properties. They want to give who the delegate is, which is literally which class will act on behalf of the table to give it its data, to do code behind for it. And then the data source is where does it get its data from. That's kind of a weird pattern. And so what Xamarin said is we're just going to combine these two into a Xamarin specific property just called source. And it says, it uses the UI table view source subclass, and it acts as both the delegate and the data source. So you don't have to set both properties when you're doing this in Xamarin. You just have to set the source, and you set it equal to a class that you create called tasks table view source. So we'll go over to our Solution Explorer here and find that class on the left. We'll double click on it, and you can see this is code that we implemented. You can see we're leveraging an observable collection of tasks of to-do items. That's our model. So this is the model piece of the pattern is to-do item. And this is very similar if we go up here. If you watched our previous videos on Android, we had a class called task list adapter. And these look very similar. This is an adapter to show a list of tasks, and we hold on to an observable collection of tasks, and we override a property to tell it what the count of the items are, and we provide a method for it to build the actual UI. That's what we did in Android. If we go back to iOS now and look at the task table view source, you'll see we hold on to a collection of tasks. We hook collection changed, which we're also doing in Android. We provide an override to tell the counts, to tell the list how to count how many items are in it. And then we provide a method for building the UI. And it's called getCell in this case. So the first thing we do, we take in two parameters. We take in the actual UI element itself. So this is a task table view source. We need to take in an actual table view to hook up to. And we take in the collection of tasks. So this is the data that we want to show. We store off the collection of tasks in a private class variable so that we can hang on to that reference. And then we hook on to that variable's collection changed event. So notice this is an observable collection. So whenever items are added to the collection or deleted from the collection, we'll get a collection changed event raised. So we just hook into collection change, and then we're looking to see, is this a new item, if there was anything added. And in our app, those are added by typing in this box and clicking add. So let's take a look at that one more time. We flip back here to our view controller. When you type in the box and you click the add button, we call add new task. That adds a to-do item to the task manager's collection. So task manager.to-do items gets modified here. And in this line, we told the task table view source that task manager.to-do items is the data source that we want to use to show on screen. So this is kind of the steps that we did in Windows Phone around data binding. We don't have a direct data binding syntax in the UI. We've got to go through this intermediate view source class, very similar to the intermediate adapter class that we did in Android. So we pass in the to-do items and we hook on when it's changed. And so when it's changed from the UI, we check to see what got added. And then we go through the items that got added. We look at the to-do items and we create a list of the new paths. And then we call the table view itself and we insert those rows. So our UI only allows you to add one at a time, but this method would handle if you were able to add multiples at a time. And so we're going to the UI element and we're inserting rows. And this is where we can give the animation of what we want to do. And we're going to call insert. And when we call insert, there's this overridden method here. This is the second part of the two pieces that Xamarin collapses together. They collapse together the data source piece and the delegate for generating the UI. So when you insert a row into the table, you'll get this get cell column called. And that will give us the ability to set what the label text is for that cell. So we'll do a little bit of code here to get a hold of the actual physical cell. This is the item that got added to the table. And then we'll make sure to add a text label to it and set its text to whatever the text of the to-do item is that we're on. So we're iterating through our observable collection. We say go find the one at this index and give me its text property and make that the text of the cell. So we're doing a little bit of the data binding plumbing that you would get for free in Windows Phone. Now we have a couple other features of this. When you click on an item, we change the text color and we add a check mark. And we're actually marking that task as complete. So we have an override for our table view on row selected. When the row is selected, we figure out what the is completed setting is for that item in our task list. So this is going back to our task manager observable collection here. And we're saying, is this completed or not completed? So we're inverting the is completed flag and setting the completed to the inverse of what it was, right? So the new is completed value is the inverse of the old value, and set the current tasks is completed to that new value. And then we go and get the cell that the actual item itself at the given index that we checked on. And then we use that new is completed variable and we decide if it's newly completed, if we just set it from is completed false to is completed true, then we want to make the cell a check mark. If we set it from completed true to completed false, then we want to get rid of the check mark. So this is a little built-in iPhone specific UI stuff here where we're able to set the cell accessory, what they call the cell accessory. So this current task I'm on is completed as false. When I click it, it sets it to is completed true and turns that check mark on. And on top of that, we also change the text color here from green to black. And we can see all of this work. We can put a breakpoint in here by just clicking in the gutter like Visual Studio. We can click on our task. Now, if we actually run, let me run this. So I'm going to click run. What I was running there was just a launched version off the emulator. I wasn't actually attached with the debugger. So we'll go ahead and run this. And we'll go into our application here and we'll type in task 1 and add it, and task 2 and add it. Let's add one more, task 3 and add it. We'll click on the middle one, and now you can see we got the row selected event happening. And now we can look to see what the is completed value. So right now is completed is false for the one that we're on. So we can step over and we can see that now we're going to set it to true. So we're going to set the actual is completed flag to true. And then we're going to pull out the individual cell at the index that we're looking at. So that cell is the UI element, the UI item of what we're on. You can see its text is set to task 2. And now its accessory right now is none. And because it's newly completed, we're going to set its accessory to be a check mark. And then we're going to change its text to green. We'll go ahead and run that. And you can see that that's turned on. And the same thing, we uncheck it. We come back here, we're switching it now to false. So we toggle the is completed. Right now it's is completed is true. And we're going to switch it to false, and the rest of the stuff will flip back. So that's how we do the check mark for completed and how we change the text. Now to turn on delete is pretty straightforward. It's two settings. The table view has the ability to have the swipe to delete already built in, and you just need to override a method called canEditRow inside our table view source and just say true. And that allows us to edit the row that we're on, which turns on swipe to delete. So since we have that setting on, if I click and swipe to the left, I can turn the delete on. I can do it slowly so you can see what's happening. Our task is flying off screen here because we have a little more UI work to do. But we can turn on swipe to delete, and that gives us a delete button. And now when you click delete, when you basically finish your edit, you override another method called commit editing style. And that gives you a parameter to tell you what editing style was being done, what type of edit happened on the row. And we look at that and say, if we were doing a delete, then what I want to do is go remove the task from the collection and delete the physical UI row that's on screen. So we'll put a breakpoint here. We've swiped, let's swipe to delete on task 2, and we click delete, and we can see if we hover over tasks right now, and we have task 1, task 2, task 3. That is our current observable collection. I'm going to step over here and do a remove, and now if we hover over tasks, you can see I have task 1 and task 3. So we deleted that item out of our observable collection. That was our model object. Now we need to also go and delete and if I can click back here, you can see that row is still on screen, even though we've deleted it from the observable collection. Now I'm going to step over and say delete that row physically from the screen. And if I come back and now run this through, now you can see it animates away. So that's how we wired up the delete. Let me go ahead and stop running so we can see a little more code. So we overrode canEditRow and we overrode commit editing style. And that's how we wired up the swipe to delete. And then this last override again is just the rows in section. That's to tell the table view how to know how many rows are on the list, and that count is just the count of however many tasks are in our model. So one last piece for our application. One thing we added, I'm going to go back in here and launch our app. One thing we added just as a nice feature is you can type with your keyboard and then press enter, and it will add. You don't have to click the add button. So we wanted you to press enter, and also you can't quite see it, but I'm going to type task 3 and then go down here to the on-screen keyboard and hit return, and that works as well. So if you were typing physically on your device and you just hit the return button, you wouldn't have to move your finger to tap add. So that's just a nice to have feature. And the way that we did that is going back to our controller here. We have the new task text. That's this text box up here. We hooked to a property called delegate. And again, this is the third or fourth time we've seen the word delegate in iPhone. Just remember, it's not the same meaning as C# delegate. This actually means you can set a class to act on behalf of the text box. So you can intercept the text box events by giving it any kind of delegate you want. So we created a class called new catch enter delegate. And if we go over to the left here, we can see it in our Solution Explorer. We can also right click on the class name and say go to declaration. And what the catch enter delegate does is it's a UI text field delegate that lets us intercept or act on behalf of the text field. And we want to override one method, should return. And when should return is called, we can tell the text field to resign its first responder duties and return true. So by default, if you press enter in a text box, it could allow you to go to the next line, for instance. We don't want that to happen. If you press enter, we want the text field to not be the first responder. Just give up on first responder and let the rest of the system fire. So when we do that, then that catches the enter, and then we can hook here on add. We can hook the new task text editing did end. So I've typed in the box and I've pressed enter, and my catch enter delegate has said we're done. I've returned true at this point, which means editing is done inside the text field. So that's going to raise the editing did end method. And so then we catch new task text editing did end here. And we say when that happens, when you're done editing, add the new task. So if you touch up inside the add button, we'll add the new task. Or if you finish editing on the text box, we'll add the new task. And by pressing enter, that triggers the editing did end method. So when I come in here and add another task and I press enter, that fires, and we can put a breakpoint here. And we'll go put a breakpoint inside our catch enter delegate here. And we'll try this one more time. We'll say task 5, enter. Oh, we weren't running. Let's try that one more time. Well, I was just running outside the debugger there. So we'll go ahead and launch. And we'll go to our emulator, bring up our app, and we'll say task 1, enter. And now the catch enter delegate has fired, and it's saying, should I return? Should I finish editing this text field because they pressed the enter key? And we're going to say, yes, you should. Give up your normal duties for listening for enter and go ahead and return true. And now we press play there. Oh, we missed that second breakpoint. Let's do this again. Task 2, enter, press play here, and there we go. And now it goes into the editing did end method, and it's saying go ahead and add the new task. So that's the way we got the enter button to work there on iPhone. Okay, so that's an overview of the TODO application in iOS, and it's very similar at this point to the Android app. If you followed along with this series, you should be pretty familiar. The key to this whole series of cross-platform mobile is this common application here, this common library here, which if we look at the options, we can see is a portable class library. And by making it a portable class library, we can target Android and iOS with the same set of code. By doing that, we're able to share this task manager class. And this task manager class is where we store our data. This is where we can get into persistence in the future. We can store everything in a common way. And we can add more functionality inside of this common library and then share it across all the applications. So again, the basic anatomy that we care about inside this app, there's a main CS that tells us what class is the delegate. The delegate tells us what class is the view controller and which window is the main window and how they're hooked together. And then inside our controller, we wire up all of the handlers for button clicks and text editing. And to see the UI and design the UI, we open the zip file in Xcode, and that's where we can drag and drop components to lay them out for our UI.